Welcome to this video, Algebraic Phrases of the form ax plus b. An algebraic phrase ax plus b, where x is a changing value and a and b are constants, contains two parts. We call each of them an algebraic term. So here we have the algebraic phrase ax plus b. The first term is ax. We call it the changing term, and it contains a coefficient, which is a, which is usually a number, a real number, multiplied by x, which is the variable. Whereas in the second term, we have b, which is called a fixed term, and it can take also any real value. Let's take an example. If we have a group of algebraic phrases here, then we want to fill the rest of columns in the table. In the first column, we want to fill the coefficient, and then the variable, and then the fixed term, using the definition of the algebraic phrase of the form ax plus b, which we saw on the previous slide. So here, 3x plus 2, we can see that the value of a is equal to 3 in this case. So we write here 3. The value, the variable here is x, as we see by comparing the form. And the fixed term, here we have b, here we have 2. Now let's take the second phrase. We have 7x. Here it could be written also as 7x plus 0. We have the coefficient is 7. And the variable is also x. And b equals 0 here. Let's see the last example, half y minus 5. We have here the coefficient is half, the variable is y, and the fixed part is minus 5. To calculate the value of the algebraic phrase at some given point x, we replace x by this value. For example, if we take the first phrase, which is 3x plus 2, and if we are given that x equals 3, then if we replace x equals 3 in this algebraic phrase, we get the value of the algebraic phrase when x equals 3. So this gives us 3 multiplied by 3 plus 2 equals 11. Let's take a practical example now. Let's assume we have two envelopes of money. Each contains x euros. So we have x euros in this envelope and x euros in that envelope. We want first to write an algebraic phrase that is equal to the total amount of money in both in the envelopes together, we can say. So if we have the first one x and in the second one x, so in the two envelopes we have 2 multiplied by x. We don't forget the 3 euros, the coins we have here. So the total amount of money that we have then is 2x plus 3. This is the algebraic phrase that we are seeking. Now in the second question, how much money is there when x equals 50 euros? So we need to replace x equals 50 in the algebraic phrase. This gives us, that is when x equals 50, 2 multiplied by 50 plus 3, this gives 103 euros. Now we introduce the like algebraic terms. Two algebraic terms are like if they contain the same variable that is raised to the same power, or they are both fixed terms. Let's take an example. 6x and 3x. We notice here that they contain, those two terms, they contain both x as a variable, so we can call them like terms. However, 6x and 3y are unlike terms since they contain different variables. Let's take another example. 3 and 4 are like terms because they are fixed terms, they are constants. However, 3 and 4y are unlike terms, okay? Because here we have the variable y and here we have a fixed term. So they are unlike. Let's take a test. Which of the below terms are like terms? So we can simply find that 3x and x are like terms as they both contain x as a variable, and 4y here and minus 7y are also like terms since they contain y as a variable. And finally, we have the fixed terms 5 and 8. So they are also like terms. Now we will learn how to add algebraic phrases. Let's assume, such we saw in the previous example, that we have two blue envelopes here. Each contains an amount of money that is equal to x. And we have 3 coins. In the other square here, we have 3 envelopes, each contains x, euros, and 1 coin. And we want to express each of these squares in an algebraic phrase. So in the first square, we have 2x, that is the amount of money in the 2 envelopes, plus 3 euros. In the second square, we have 3x plus 1 euro. Now let's assume that we take all of this money and we put them in this box. So now we take the 2 envelopes from here and the 3 envelopes from here, and we put them all together, so we get 5 envelopes. Again, we take the 3 coins from here in addition to the 1 coin from here, and we put them together here, so we get 4 coins. And now, since each of these envelopes contains x euros, so the total amount of money in these envelopes will be 5x. And here we count 4 euros. Now, let's forget about the picture and look only at the algebraic phrases. So here we have an algebraic phrase, and here we have an algebraic phrase. And here is another algebraic phrase, which is the value of the total amount of money that is taken from the 2 squares. If we check the terms here, we will find out that the 5 that exists in the changing term of this collection of money is equal 2 plus 3, where 2 is taken from the first square and 3 is taken from the second square. So in order to sum or to add the changing terms that are like terms, we sum the coefficients and we multiply the result by x. So here 2 plus 3 equals 5, and we multiply this by x. Regarding the fixed terms, we also directly sum them. So here we have 3, which is 3 coins, and here we have 1, which is 1 coin. So we add them to give us 4 coins. Now multiplying algebraic phrases. Before multiplying algebraic phrases, we mean by it multiplying it by a number. So first of all, we learn how to multiply a changing term by a number. In order to multiply a changing term by a number, we multiply this number by the coefficient that exists in the changing term. So here is the changing term. Here is the coefficient, and here is the number we are multiplying the changing term by. So minus 3 multiplied by minus 2y will be like minus 3 multiplied by minus 2, which gives us 6, and we multiply the result by y. Let's take another example. 2 multiplied by 2y. So it is like we multiply 2 by 2, and then we multiply the result by y. This will give us 4y. Now the distribution property, and we will use it in case we want to multiply a number. We multiply the algebraic phrase by a number. So when we multiply an algebraic phrase by a number, we multiply all terms in the algebraic phrase by that number, and we sum the results. We add the results. For example, 3 multiplied by the algebraic phrase 4x plus 2. So first, we multiply 3 by 4x. This will give us here 3 multiplied by 4x, and then we multiply 3 by 2. 3 by 2, and we add the two results together. From the first one, we get 12x, and from the second one, we get 6. We cannot simplify it further since we are not given a specific value of x. Transforming a text to an algebraic phrase. Let's take an example. Sami is 8 centimeters taller than Ahmed. Based on that text, write an algebraic phrase that shows the height of Sami in terms of the height of Ahmed. So let's start by giving the height of Ahmed the value x. Okay. Since Sami is 8 centimeters taller than Ahmed, then the height of Sami will be x plus 8, since x is the height of Ahmed. So this is the height of Sami. Okay. Now, if the height of Ahmed was 175, find the height of Sami. So again, the height of Sami in this case, when x equals 175, we replace it in the algebraic phrase. So we get 175 plus 8, and this is 183 centimeters. Let's take another, a bit more difficult example. If the age of Sami is 3 years less than the double age of Ahmed, write an algebraic phrase that shows the age of Sami in terms of the age of Ahmed. So first thing we think about is we want to represent the age of Sami in terms of the age of Ahmed. So we start by giving the age of Ahmed the value x. Now, age of Sami 3 years less than the double age of Ahmed. So what is the double age of Ahmed? It's 2x. 2x minus 3 will give us the age of Sami. And this is the required algebraic phrase. If Ahmed is 20 years old, find the age of Sami. So we replace x equals 20 in the algebraic phrase that we got on the first part. So we get 2 multiplied by 20 minus 3, this will give us 37 years, which is the age of Sami. The last example, write an algebraic phrase that shows the circumference of this triangle in its simplest form. So we have here the circumference equals the sum of the values that we are given. So it's x plus 8 plus 2x plus 1. Here we have 2x and x are like terms, and they are changing terms. We sum the coefficients. Here we have 1 and here we have 2, so we have 3, and we multiply this by x, then we sum the fixed terms, so it's 3x plus 9. This is the algebraic phrase. If x equals 3, calculate the circumference of that triangle. So when x equals 3, then we have 3 multiplied by 3 plus 9, this equals 18. We can also, from x equals 3, we can derive the value of 2x plus 1, which is 2 multiplied by 3 now, after we know it, after we know the value of x, plus 1, and this will give us 7. So here we have 3 and 7 and 8. If we sum them, we will get again 18.